Arguments against shared neutrals include safety concerns. A lost or broken neutral can result in overvoltage on the affected circuit, potentially causing electrical shocks, fires, or damage to equipment. Diagnostic difficulty arises because if a neutral is shared, it can be difficult to isolate the source of a problem, as multiple circuits may be affected. Circuit breaker confusion can occur where, when shared neutrals are used, circuit breakers may not trip properly, leading to underprotection or false alarms. Reliability issues are a factor because as more loads are added to a shared neutral, the risk of overloading increases, potentially causing voltage drops or circuit failures. Maintenance challenges become apparent when servicing or replacing a single circuit with a shared neutral requires accessing multiple circuits, which can be inconvenient and time-consuming. Arguments for shared neutrals include cost savings. Using shared neutrals can reduce the number of wires and conduits required, lowering material and labor costs. Conduit fill reduction can happen because by combining the neutral wires, the conduit fill is reduced, allowing for more circuits to be installed in a given space. Acceptable risk can be considered in some cases such as in low-load applications, for example, lighting circuits. The risk of neutral loss may be negligible, making shared neutrals an acceptable option. In conclusion, while shared neutrals may offer cost savings and conduit fill reduction, the potential safety and reliability risks should be carefully considered. In general, it is best practice to avoid shared neutrals unless specifically permitted by the National Electrical Code or local regulations. For safety, reliability, and ease of maintenance, using separate neutrals for each circuit is the recommended approach. A shared neutral circuit, also known as a multi-wire branch circuit, or MWBC, is an electrical wiring technique where two or more hot wires share a single neutral wire. This configuration can save on wiring costs and reduce conduit fill, as fewer wires are required compared to running separate neutral wires for each circuit. However, it also introduces potential safety and operational concerns if not implemented and maintained correctly. Here's a detailed look at the risks and benefits of shared neutral circuits. Firstly, we will discuss the benefits of shared neutral circuits, namely cost savings. One of the primary benefits of using shared neutral circuits is the reduction in material costs. By using one neutral wire for multiple circuits, the total amount of wiring required is reduced. This can be particularly beneficial in large installations or in situations where conduit fill is a concern. Secondly, a reduction in conduit fill. Fewer wires mean less conduit fill, which can allow for more circuits to be run in the same conduit. This can be advantageous in applications where space is limited or when adding new circuits to an existing system. Now, we will explore the risks associated with shared neutral circuits. Firstly, safety risks of overloading the neutral wire. The neutral wire in a shared neutral circuit carries the unbalanced current from the hot wires. If the loads on the hot wires are not balanced, the neutral wire can become overloaded, leading to overheating and potentially causing a fire. Secondly, overvoltage due to a lost neutral. If the neutral wire becomes disconnected or broken, the voltage on the circuit sharing the neutral can become unbalanced. This can result in some devices receiving a higher voltage than they are designed for, potentially causing damage to the equipment or creating a safety hazard. Thirdly, harmonic currents. Nonlinear loads, such as electronic devices and some types of lighting, can generate harmonic currents that flow through the neutral wire. These harmonic currents can cause the neutral wire to overheat, even if the loads appear to be balanced. Fourthly, diagnostic challenges are an issue because troubleshooting shared neutral circuits can be more complex than troubleshooting circuits with dedicated neutral wires. Identifying the source of a problem can be difficult, as multiple circuits are interconnected through the shared neutral. Fifthly, nuisance tripping. Problems with the neutral wire can cause circuit breakers to trip unnecessarily, disrupting power to multiple circuits. Shared neutral circuits can be safe and effective if they are properly designed, installed, and maintained. However, it is essential to be aware of the potential risks and to take steps to mitigate them. Here are some best practices for using shared neutral circuits. Firstly, proper circuit design. Ensure that the loads on the hot wires are balanced to minimize the current flowing through the neutral wire. Use appropriately sized neutral wires to handle the maximum potential current. Secondly, professional installation. Shared neutral circuits should be installed by qualified electricians who understand the potential risks and how to mitigate them. Thirdly, regular maintenance. Inspect the wiring regularly to ensure that connections are tight and that the neutral wire is not damaged or corroded. Use appropriate testing equipment to verify that the circuits are functioning correctly. Here are some situations when shared neutral circuits may not be appropriate. Firstly, high-load applications. Avoid using shared neutral circuits in applications where there are heavy or unbalanced loads, such as in industrial settings or with large appliances. Secondly, sensitive electronic equipment. Do not use shared neutral circuits to power sensitive electronic equipment, as voltage imbalances and harmonic currents can damage these devices. Thirdly, older wiring systems. Be cautious when working with older wiring systems, as the neutral wires may not be adequately sized or in good condition. The National Electrical Code, or NEC, has specific requirements for shared neutral circuits to ensure safety and prevent potential hazards. These requirements cover aspects such as wire sizing, overcurrent protection, and grounding. Here are some key NEC requirements related to shared neutral circuits. Firstly, identification. The NEC requires that multi-wire branch circuits, which include shared neutral circuits, be clearly identified at the panel board to prevent accidental disconnections. Secondly, simultaneous disconnection. The NEC requires that all conductors of a multi-wire branch circuit be disconnected simultaneously by the circuit breaker or disconnecting means. This helps prevent the neutral wire from becoming overloaded if one of the hot wires is disconnected. Thirdly, ground fault protection. The NEC requires ground fault circuit interrupter, or GFCI, protection in certain areas such as bathrooms and kitchens to protect against electrical shock hazards. GFCI protection can be more complex to implement with shared neutral circuits, so special attention is required. Fourthly, arc fault protection. The NEC requires arc fault circuit interrupter, or FSI, protection in many areas of the home to protect against electrical fires caused by arc faults. FSI protection can also be more complex to implement with shared neutral circuits. In conclusion, shared neutral circuits can be a cost-effective and efficient wiring solution, but they also introduce potential risks that must be carefully managed. By following best practices, adhering to NEC requirements, and ensuring that the circuits are properly designed, installed, and maintained, it is possible to use shared neutral circuits safely and effectively. Always consult with a qualified electrician to determine the best wiring solution for your specific application. The specific requirements are outlined in the National Electrical Code, particularly in Article 210.4 regarding multi-wire branch circuits. This section details the conditions under which shared neutrals are permitted and the necessary safety measures. The NEC emphasizes the importance of proper overcurrent protection and ensuring that the neutral conductor is adequately sized to handle the maximum unbalanced load. Here is a deeper dive into the safety concerns associated with shared neutrals. The primary concern with shared neutrals is the potential for overloading the neutral conductor. In a standard circuit, the neutral wire carries the current returning from the load. However, in a shared neutral configuration, the neutral wire carries the unbalanced current from multiple hot wires. If the loads on these hot wires are not balanced, the neutral wire can become overloaded. This overloading can lead to overheating, which can melt the insulation around the wire, creating a fire hazard. Even if a circuit breaker trips due to an overloaded hot wire, the shared neutral may still carry current from other circuits, exacerbating the overheating issue. Another significant safety concern arises when the neutral wire becomes disconnected or broken, often referred to as a lost neutral. In a properly functioning shared neutral circuit, the voltage between each hot wire and the neutral wire is typically 120 volts in a standard residential setting. However, if the neutral wire is disconnected, the voltage on the circuit sharing the neutral can become unbalanced. This can result in some devices receiving a voltage significantly higher than 120 volts, while others receive a much lower voltage. Devices that receive the higher voltage can be damaged or destroyed, posing a fire risk or causing electrical shocks. Nonlinear loads, such as electronic devices, computers, and some types of lighting, generate harmonic currents that flow through the neutral wire. These harmonic currents can cause the neutral wire to overheat, even if the loads appear to be balanced. In shared neutral circuits, the problem is compounded because the neutral wire is already carrying the unbalanced current for multiple circuits. The increased heat can degrade the insulation and potentially lead to a fire. Proper installation is crucial for the safe operation of shared neutral circuits. The NEC mandates that multi-wire branch circuits, including those with shared neutrals, must be clearly identified at the panel board. This identification helps prevent accidental disconnections during maintenance or repairs. Additionally, the NEC requires that all conductors of a multi-wire branch circuit be disconnected simultaneously by the circuit breaker or disconnecting means. This ensures that the neutral wire does not become overloaded if one of the hot wires is disconnected. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock hazards by detecting ground faults, which occur when current flows through an unintended path to ground. In shared neutral circuits, implementing GFCI protection can be more complex. Standard GFCIs are designed to monitor the current balance between the hot and neutral wires of a single circuit. When a shared neutral is used, a ground fault on one circuit can affect the current balance on other circuits sharing the same neutral, potentially causing nuisance tripping or failure to detect a ground fault. Arc fault circuit interrupters, or SIs, are designed to protect against electrical fires caused by arc faults, which are dangerous electrical discharges that can occur when wires become damaged or connections become loose. Similar to GFCIs, SIs monitor the current flow in a circuit and detect abnormal patterns that indicate an arc fault. In shared neutral circuits, the presence of multiple circuits sharing a single neutral can complicate the detection of arc faults. The FSI may not be able to accurately distinguish between normal current fluctuations and those caused by an arc fault, leading to nuisance tripping or failure to detect a hazardous condition. Troubleshooting shared neutral circuits can be more challenging than troubleshooting circuits with dedicated neutral wires. Because multiple circuits are interconnected through the shared neutral, it can be difficult to isolate the source of a problem. For example, if a circuit breaker trips, it may not be immediately clear which circuit is causing the issue. Similarly, if there is a voltage drop or other electrical problem, it can be difficult to determine which circuit is responsible. In terms of cost savings, using shared neutrals can reduce the number of wires and conduits required, lowering material and labor costs. This can be particularly attractive in large installations where the cost of wiring can be a significant factor. However, it is important to weigh the cost savings against the potential safety and reliability risks. Reducing conduit fill can be achieved by combining the neutral wires. The conduit fill is reduced, allowing for more circuits to be installed in a given space. This can be advantageous in situations where space is limited or when adding new circuits to an existing system. However, it is essential to ensure that the conduit is not overloaded, as this can lead to overheating and other problems. In some low-load applications, such as lighting circuits, the risk of neutral loss may be negligible, making shared neutrals an acceptable option. For example, in a small office with only a few lights on each circuit, the unbalanced current in the neutral wire may be minimal. However, it is still important to follow best practices and adhere to NEC requirements to ensure safety. The National Electrical Code, or NEC, provides specific guidelines for the use of shared neutrals in electrical installations. These guidelines are designed to ensure that shared neutral circuits are installed and maintained safely. Some key NEC requirements related to shared neutrals include: firstly, identification of multi-wire branch circuits at the panel board; secondly, simultaneous disconnection of all conductors of a multi-wire branch circuit by the circuit breaker or disconnecting means; and thirdly, compliance with ground fault protection requirements in certain areas, such as bathrooms and kitchens. It is important to consult the latest edition of the NEC and local regulations to ensure compliance with all applicable requirements. It is generally recommended to avoid shared neutrals unless specifically permitted by the NEC or local regulations. For safety, reliability, and ease of maintenance, using separate neutrals for each circuit is the preferred approach. This eliminates the potential for overloading the neutral wire, reduces the risk of overvoltage due to a lost neutral, and simplifies troubleshooting and maintenance. Shared neutral circuits can be a cost-effective and efficient wiring solution, but they also introduce potential risks that must be carefully managed. The potential for overloading the neutral wire, the risk of overvoltage due to a lost neutral, and the challenges of troubleshooting and maintenance are all important considerations. By following best practices, adhering to NEC requirements, and ensuring that the circuits are properly designed, installed, and maintained, it is possible to use shared neutral circuits safely and effectively. However, it is important to weigh the cost savings against the potential risks and to choose the wiring solution that is best suited for your specific application.